Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
My name is Suzanne Miller. I'm a principal researcher here in the SEI Software Solutions Division. I'm very pleased today to introduce you again, for some of you, because they've spoken with us before, to Dr. Robert Nord, we call him Rod, and to Dr. Ipek Ozkaya, also from Software Solutions Division. And they're going to talk to us today about technical debt, how it impacts software cost, and other aspects of technical debt that software engineers and managers need to know about. But before we get started on that topic, for those that haven't listened to our podcast before, could you give us each a little bit about your background and sort of what drew you to the SEI and in particular to this research? And why don't we start with you, Rod?
Okay, well, thank you, Suzanne. Prior to working at the SEI, I was working in an industry R&D lab about the time when the idea of software architecture was just emerging as a software engineering discipline. So I had an opportunity to talk to developers and engineers throughout the company and in the business units, and to ask them, how do you describe and represent the software in the large-scale systems that you're building? So, they would draw like different pictures, and from that, I would start to think about, how do we start to codify those representations in terms of documentation, so that we could start to codify those practices and everyone could take advantage of it. And once we write those things down, then we can start to ask some questions, and then from there start to think about, well, how do we codify the analysis, the evaluation that takes place, and then we talk about the rationale, and that gives us a little bit better insight into design. So when I joined the SEI, we had these different methods for analyzing, describing, designing architecture. So then I got interested in thinking about, well, how do they fit together, or how do we fit them in with other practices like Agile, or in terms of a larger software development lifecycle. So since there was such great interest in Agile, that was one of the areas that I focused on. And with Agile, it brings a new challenge, because with Agile we wanted to start to think about what can we produce in terms of a minimal viable product every week or two in terms of these short sprints. And so now we have that challenge, like how do I decide what I want to do in the short term in terms of meeting my minimal viable product objectives, but at the same time, those decisions that I make, I want to ensure that I can still be productive in the longer term and not undermine productivity. So then that kind of led me to an interest in technical debt, in trying to understand how that trade-offs of short-term and long-term played out.
Yeah, and that's really what this is going to be about, is how do we make those trade-offs. Ipek, how did you come to be involved in this work?
So I come from a design background as well, but are a little different. Before joining the SEI, I was at the Carnegie Mellon University side of things and working on my PhD in research in an area called computational design. What that is to develop software tools for typical design professionals. It's a very interdisciplinary field. So at any day, someone who needs to build a design product, be it a house, be it an industrial design product, needs to work with someone who is in the software business to be able to actually bring it to life, to be able to draw about it, to be able to reason about it. So that was where my work was in terms of understanding how these different professionals talk to each other, and what does it mean to develop computational tools, which are design tools there's an overload of the design perspective. So there, a lot of the challenges that I realize is whether people are talking the same language and how do they make the trade-offs. It's very similar, but from a different perspective, design trade-offs. So then after I finished, I joined the SEI, and their software architecture takes a different form, but with the same principles. And again, how do you make these trade-offs? And people oftentimes overlook the long-term consequences as well as the short-term importance. You cannot wait too long to make that prototype. Putting something out there is as valuable as making the right decision. And that's a very challenging trade-off. And when the concept of technical debt fell on our lap, it was actually very eye-opening, because it's very vivid from communicating that, and it's very powerful because it can communicate it to a product manager, to a project manager, but to a developer as well as a domain expert who may not understand the technology that actually recognizes it.
Technical debt is a very easy metaphor for people to understand, because most of us, at least, I can't speak for everyone, but most of us do have debt in our non-work lives, and so that concept immediately resonates. How am I going to pay it off?
Correct.
Right. That's one of the questions, and that's the same question that we have to ask in the software world: is if you're going to incur this, how do you pay it off?
Correct.
And so let's get into the meat of it. So you've been studying technical debt for several years. I've worked with you in some of the areas. I had some fun, developing some ways of communicating about this. What is the most important thing for people to understand about technical debt today? What have we learned about technical debt and sort of how it occurs? And how do we manage it? How do we make those trade-offs? And how do we answer that question? How are we going to pay it off? So, Rob?
Yeah, so from a practical experience, I think a developer would experience technical debt as a source of friction. So have they made decisions in the past that are now slowing them down? So it's causing extra work and decreasing productivity. And the other aspect is that even though technical debt is visible to the developer, it's largely invisible to the rest of the organization or to the users of the system, who might be more focused on the features but not have such insight in terms of the extra work that the developer is incurring.
So let's talk about an example of intentional technical debt, because we have both kinds: intentional technical debt and unintentional. We'll talk about the other one in a minute. But an example for me for intentional technical debt would be, as you said, I have a minimum viable product that I need to demonstrate that we can execute some kind of an algorithm. And when I write the code for that algorithm, I don't write it in the most efficient way possible. If we were to take the code that I wrote for that algorithm and actually put it in the field, it would have bad performance, right, in terms of what's expected. But I can at least demonstrate the feasibility of, yes, we can execute that algorithm. And in the short term, that's, as you said, sometimes having the prototype demonstrating feasibility, it has a lot of value. So I've intentionally incurred some technical debt. And how do I, as a developer, how should I communicate that to people? Not just, hey, great for me, I got this algorithm done, but, oh yeah, but by the way, we're going to have to deal with this later. How do people deal with that in today's world?
So that's an excellent example. So as we said, software is about trade-offs, and in this case, if you have a deadline, it may make sense to intentionally incur debt. Just as you were mentioning with the metaphor, we might take out a loan, a mortgage for a house where we're getting some short-term benefit. And the key idea, as you said, is to take that with intention. I'm consciously making that decision, but then bringing that awareness to your team and to the organization. So one way of doing that is to put that into your registry. So if you have a backlog where you have user stories or features, then it makes sense at the same time as you're incurring that debt is to create another issue for your backlog that this is a technical debt. It makes sense at this time to incur it, but once it's in the backlog, then you can start to monitor it. So there, as you said, if it's a kind of an expedient solution to make this deadline, it may start to slow you down, and that's a form of interest. So then you have to kind of monitor that interest to see, well, is it worthwhile paying a little bit longer to get that immediate benefit? But then as you start to plan future releases, you can start to anticipate what those interest payments might be and when you might pay that off.
Right. So, for example, I may make an explicit decision that when we go back to this module where this algorithm occurs, later we're going to have to do other things, other stories with it. That's the time at which we're going to bring in performance tuning, I'll call it, to get rid of the technical debt on that. Are people actually doing that? That's one of my questions. I know we recommend these things, but are you seeing evidence of changes in practice in our user communities that are actually saying, yes, I'm going to be explicit about this technical debt. I'm going to put it in the backlog. I'm going to decide when I'm going to deal with it. Because I know 5 years ago, I wasn't seeing much evidence of that, and I'm just curious what you've seen since then.
I think people are starting to recognize it, and more importantly, I think they're using some of these mechanisms that are already available to them to communicate it. So we look into some of the code comments, for example, or the issues that actually they do talk about technical debt, and they talk about it correctly. They, for example, developers find out an unintentional technical debt and say, over time, we knew we had to change this interface. We didn't because other priorities kicked in. Now, if we don't do it, we're going to actually be in much more trouble in refactoring it. So this vocabulary is in the developers' common vocabulary. Some organizations are more savvy and actually create the labels where they put the technical debt in their backlogs or manage it. Others make it more organic to the development environment. Other organizations actually fear technical debt because they think, okay, it's maybe going to incentivize, but they try to have other mechanisms to help developers to really
They fear making the technical debt too big.
Too big. So it is definitely in the vocabulary of the developers. It's also much more common to understand. Like, for example, we also see examples where, oh no, this is not technical debt. This is actually a bug that shouldn't have been there. So there's this subtlety that the developers have also appreciate and talk about. So that's actually very encouraging because that means we're starting to manage it, we're starting to recognize it.
Although I will say I still have to correct a lot of people more in the management side than the engineering side, that they have this equivalence between technical debt is all the defects that have built up.
Yes.
And that's not a true statement. Defects can incur and can generate technical debt the same way intentional decisions do, but the bugs themselves, the defects themselves, are a whole thing that need to be managed on their own.
And the subtleties are not very easy to differentiate, and that's actually, we were very fortunate to interact with people who are in the trenches as well as tool vendors who recognize some of these, because over time those defects become significant symptoms. But when do you recognize them as symptoms versus technical debt versus defects? And that's, I think, where our work has actually established and helped some of it in terms of making the differentiation, recognizing that defects are actually symptoms, and some of those defects need to be treated differently. Hence, maybe you need to label it differently as well. So I think that's where it's helpful.
Yeah, so that was part of the process of moving from the metaphor to start to think about, the theoretical underpinnings and then the practice. So as Ipek was saying, just rather than just talking about technical debt, we want to think about, what are the symptoms or the consequences, and then, trace that back to a concrete development artifact. So what is the actual code or the architecture, that decision that was made that is the source of the technical debt, as well as differentiate that from the consequence. So perhaps like you're in a deadline-driven environment that provides an environment where maybe people are creating unintentional technical debt. So it's important to understand the environment to make changes, for the longer term. But then just changing the environment doesn't really change, the actual artifacts. So you need to think of it in terms of those three components: the symptom, the development artifact, and the consequence.
And so I had a very interesting conversation with someone who is in an organization that has made the choice that they are, every time you touch a piece of code, if as a developer, one of your duties is to simplify it, right, as much as possible. So in many of our government settings, we have the only change what you've been told to change, don't touch anything else. And we have a lot of legacy that's fragile, and there's a lot of reasons for that. But this group kind of went the other way. They said, simplify it and don't worry about long-term effects, because we're going to turn over the software every 3 months. And I'd never heard that before. And one of my immediate reactions to that was, well, that's one way to solve the technical debt problem. But with an assumption that they are learning enough on each cycle to actually do better each time. But have you run into that pattern? And I haven't run into it in the government. This is in the commercial space.
I'm not an expert in that space, but a very similar phenomenon is talked about in the gaming industry, because the visualization capabilities, the processors, and everything changes as quickly as it does in both hardware as well as software. From their perspective, they worry about the version that is out. And again, I'm not knowledgeable and I'm not expert, but a number of years ago, that example was given to me, not necessarily in the context of just technical debt, but from the context of long-term, you might actually be better off just starting with the new capabilities that are out there, new frameworks, new hardware, and thinking of that environment rather than trying to think about reusability, evolvability, and whatnot. Of course, there's learning, and there are pieces of it that definitely probably evolves, but the focus of it might be different. So that's another example. So there's definitely the organizational and the domain aspects that might change your, I guess, perception or how sensitive you are to it. But to itself, that is technical debt management too.
Yeah, it is. It's not our normally thought of strategy, but it was an interesting, that was an interesting contrast to many of the systems that we work with. So
and that's one of the focus of our research, is to think more about the implications for managing technical debt, or looking at it from a strategic point of view. Because a lot of the tools that are coming up to try to support technical debt, focus on the code and all the hundreds or thousands of violations, and then associating a cost to fix them, the principal, if you will, and then kind of rolling that up into one large number, saying you have all this debt that you have to pay it off. But it's not always black and white. As we talked about, maybe you want to understand the principal, whether it's as well as the interest, and whether it's worthwhile to pay the interest for a while, or as you were just saying,
replace. It's going to be replaced soon enough.
Maybe it makes sense to replace or declare bankruptcy or amnesty if you're not going to be changing this for a while. Then you can.
You have some more degrees of freedom in terms of how you manage it.
And also it's like what to prioritize, right? Knowing the debt and prioritizing the new functionality or adding onto it is completely different than not knowing about it and adding onto it. Even if you decide to leave it there, the strategies that the design choices or the implementation choices you make will definitely change when you're aware of it. Even if you decide not to do anything about it, you might decide to maybe decouple it from the rest of the software. The approaches you take still protect you going forward from some of these aspects.
And in contrast, there's my father. I use this example from time. My father has a pacemaker. I really don't want people just replacing the software in the pacemaker every 3 months and saying, well, that's the old software, and we've learned more. I want a little more on top of that to make sure that there isn't anything that goes wrong in the field, right? So we definitely have systems that have long-term life cycles, and we're looking at technical debt from that viewpoint of that longer-term trade-off analysis is absolutely necessary. It's not just appropriate, it's necessary. So what's the latest in this area? We're talking about some of the sort of the basics, but what is the new thing that you've been working with, struggling with, discovered, in the last couple of years that our viewers haven't really heard about yet?
So I don't know whether this is the latest, but I think tool support to make these abstractions easier is going to be a news and the latest for a couple of more years, because automating these processes, automating these analyses are not trivial, and also they have their niche idiosyncrasies based on the language of choice, based on the framework of choice or the domain of choice. So but the good news is there are more researchers and more tool vendors who are actually within this domain and looking into it, and also integrating some of these tools into the continuous integration, continuous deployment pipelines are some of the newer approaches which will hopefully in the short term eliminate unintentional technical debt, because you'll be able to catch these obvious one at least earlier, because you have
through
the
the
tool
automation,
support.
you're going to have enough repetition of the testing and the integration cycles that you have confidence that you've actually caught the things that it's intended to catch.
Correct. So, but from a tooling perspective, being able to develop analysis tools who are able to abstract the design choices, the framework choices, that's still an ongoing work area, which makes it exciting as well as also an opportunity.
Well, and if you think about humans making choices, context, one of my favorite phrases is context is everything. And, the context in which a developer is working, how well they know the language, how well they know the domain, how well they understand the as-is architecture, the intended architecture, how well they understand the context of where their software is going to fit. All of those things, that context influences design choices. And many of those things are fixed. Language,
Correct.
Domain has a boundary, but not all of them. And so I would see that as a challenge as a tool builder of understanding where's the boundary of things that I can reason about from a computational viewpoint versus where I really have to get out and look at the comments, talk to the coders and ask the question, why? Why did you do this?
Yeah. So in addition to automation, there's also advances in what we talk about, the coverage and the technical debt landscape. So originally it got started at technical debt with a focus on code, but as we've been talking, our work has been kind of lifting that and looking at design and architecture, and so there's some promise there. Another area of the landscape is the production. So there's the build, test, deployment infrastructure. Okay. So if we think of infrastructure as code, there could be technical debt in that infrastructure, as well as in that delivery process in terms of the alignment of these different stages of testing and internal environments, as well as the deploying it to the field.
So when I don't have what we call environment parity, where I can't establish the development environment and the deployment and test environments being equivalent.
Yeah, there could be a misalignment there.
I've got some technical debt in my infrastructure. Oh, that's cool. Okay, that's new. That's new. I'm excited.
And also, we tended to think initially in terms of the source line of code. But even if we say, okay, it's the source line of code, when I change it, I need to test it. I need to put it into the overall structure, and I need to push it to the end users through the development pipeline. So it's not just that, I have code debt.
Right.
You cannot. That's not necessarily the piece. You have to really think about it from an end-to-end perspective. So that's actually important.
How easily are software architects and possibly system architects accepting the idea that they may be intentionally incurring technical debt in the products that they're creating? Because that's a tough job. I mean, the software architect, if you go too detailed, now you're imposing constraints that aren't necessary. If you're not detailed enough, then nobody knows what it is that we're doing. So, and if you do it too long, then the world changes and it's overcome by events anyway. So, how do you start communicating about that in a productive way with those higher level kinds of work products and communication mechanisms?
So in our experience, and maybe we've been fortunate, someone who's been in the field and who's experienced knows the fact that they are making trade-offs, and those trade-offs have to be communicated. So from a technical stakeholder perspective, architects, developers, we don't get any pushback.
Okay.
What I think might happen at times is, and we haven't seen the situation where they get nervous that they would be penalized for technical debt or not. On the other hand, when we talk to people, they say, could you please have this conversation with my manager as well? I think it's really them communicating, even if the managers or the non-technical stakeholders accept the fact that there is technical debt, they may not always appreciate the timelines it takes and how it might need to be resolved and what it takes to resolve them. So I think that's where our work becomes kind of a bridge between these different stakeholders and giving each of them different tools to make that communication more on the same page rather than talking above or below each other.
And so, one of the things that I know from dealing with a lot of different sides of software and system acquisition is the time from when a decision is made to the time when you actually see the effect of that decision, depending on the character of it, can be quite long. So when you have these delayed effects, it can be very difficult to get management to sign up to a decision that isn't going to have an effect for months, possibly years. And it's easier to get them to sign up for a decision that they can see the effect of very quickly. So there's some dynamics there system dynamics actually that kind of play into when managers don't understand the sort of long-term causal loops versus the short-term loops. They're more likely to make some of the short-term decisions, even if that's not the best technical solution in the sort of in the long term. So I can see where the technical debt discussion can get complicated when you start trying to make them understand some of these trade-offs of if you go with this short-term decision, then you're not going to see it in 3 months, but you or your successor is going to see it in 12 months or 18 months, and you're going to have to. It's like okay, I'm going back to the debt metaphor. It's like those balloon mortgages, right?
Yeah.
You only have to pay a little interest now, but then you're going to have the big balloon payment at the end, and and some of us are more willing to accept that than others, and none of us like it when the balloon payment comes. So that's a true thing.
Yeah, that's an active challenge. But if we think of technical debt in context, we could think of like 3 layers. So one is when we're looking at the software, we're looking at the structure of the system, and all those metrics that go along with understanding the architectural health of the system. So that's the structure. But then on top of that, then we can think of technical debt, in terms of the principal and interest, and then pointing to that structure or the development artifact that's creating those symptoms.
Right.
And so that principal interest tends to be more within the development team, and I think that's a contribution now in terms of how they can manage it. But then on top of that, is the business side. So the business risk, is there a certain liability based on that technical debt,
right,
or is there an opportunity cost? So there's been some experience that I've seen with system software architects in enterprise domain, saying that their management at least is very much attuned to this, liability, risk liability. So technical debt, feeds into that along with other factors. So by having that, conversation to show how this growing amount of interest, not just paying off the principal, which they might be, willing to kind of keep the debt, but if you can make that argument that this is how the interest could play out.
And this is the liability you're accepting from a business
that they
viewpoint.
Found that resonated more on the business side, at least for his work that he's working in.
And also, relying just on the maintainability argument is not the right thing to do as well. Yes, obviously it's about long-term maintainability, but the reason you have the long-term maintainability issues has effect in terms of the user observable or more of the performance-related or runtime-related aspects as well. So I think sometimes we get lazy and don't do that mapping and assume that different kinds of stakeholders would be able to do that mapping. Helping them make that connection actually also helps make the conversation a lot easier.
So we haven't talked about this before, so I apologize if this is a surprise discussion topic, but have you interacted at all with the model-based engineering community in terms of how using models as the representation artifact of architecture and functionality can help people to reason about technical debt as one of the things that the models reason about? I can't think of an instance right off the top of my head of a modeling activity that I know of that is actually addressing, trying to reason about technical debt. But have you guys run into that yet? Because that seems like that might be a promising area for research.
Yeah, so there's models in the broad view, and we would include dependency structure matrices as a form of model.
Right.
And then some of the source code analysis tools building on dependency structure matrices, certainly address that model of the architecture that's important for understanding the structure that we talked about and the principle and the interest. In terms of the model-based, some of the other languages, those that tend to focus more on operational qualities like performance or reliability, I would say have to be complemented, with some of these other models that focus more on the module architecture, so that we can understand the structure. And how we can support, evolving the system over time, in addition to supporting the operational qualities.
And our approach is to, at the end of the day, anchor the technical that you're talking about on a software development artifact. So
Right.
from that perspective, it's either code or tests or build scripts. So these are all software
Right, right,
artifacts.
right.
A model, in that perspective, as long as it's a software artifact, system artifact,
Okay.
can actually be part of that artifact
Sure.
analysis. We haven't done or seen analysis that runs on the models, but models generate code, right? That's
Yep,
part
that's
of that.
true, too.
And some of our analysis, we did apply into some of those codes, and some of them are
Codes that
able
were
to
generated by
that were
models.
generated, and some
Gotcha.
of it can provide insights, but of course that needs to be tested, not only necessarily on the
Mm-hmm.
model. So that's from a software artifact perspective, it's definitely relevant. But what does it mean to generate analysis on the actual model
Right,
itself
right.
from a runtime perspective? That could be of interest to some of the communities, definitely, and that could definitely be part of our framework. That's not excluded at all.
Yeah, so we've talked about infrastructure as code is one of the things. I also heard, kind of in the hallways of one of the places I was, models as code, and
Yeah, that's been around
and
for a
which
while, yeah.
they are. They are codified, views of things, but trying to look, there's the digital engineering strategy from the U.S. Federal government, trying to be more cognizant of the fact that these models depend on codifications of ideas, and if we're not going to treat them as code, we take some risk
Correct.
in the
And
models themselves.
At the end of the day, they become part of the executing, functioning
that's
system.
right.
So how is that part of the analysis? I think we sometimes fail to think it that way. We think it only as a representation,
Yeah, yeah.
but they are beyond. Some
Yeah,
of them
yeah.
are going towards the aspect that they're beyond the representation. Then you can run the code analysis and all of that, or other kinds of analysis on that.
So for viewers that haven't been involved in this work so far, what are a couple of the key resources? And all of these will be mentioned in the transcript, and the links will be in the transcript. What are some of the key resources if I'm a software developer and I'm just now becoming aware of technical debt as a concept? Where do I go? How do I get smart about this?
So there are some resources that are already available, like from our website. All of our published papers, as well as some of our tooling, will be available, like scripts of our analysis techniques are out there. We've been running the technical debt workshops now. It's
Yes.
actually going to be in its second year as a conference. The technical debt conference is co-located with the International Conference of Software Engineering.
Yes.
In 2019 in May in Montreal. So that's definitely an opportunity to both learn, to submit work, to interact with. We have different tracks, and that's also available. And for myself, Rod, and Philippe Kurten have been working on what does it mean to actually put these things into practice. So a practitioner-oriented book will be coming up later in 2019
Excellent.
in May as well, through Addison
Excellent.
Wellesley, as part of the SEI Software Architecture Series.
Oh, May of 2019, the conference.
Yeah, so we'll see. Well, that's
Okay,
the hope.
you're going to be dealing with some technical debt as you try and get towards that deadline.
We
So,
hope we're ahead of it, but
yeah.
we'll see.
No. Okay, so that's definitely something to look forward to. And what about what's the new research that you're going forward with as you kind of continue on this journey? You've got sort of that practitioner view going, but what's the more advanced stuff that makes the researcher's heart happy?
So I think we are starting to explore more in terms of the continuous integration, continuous deployment pipeline. What does it mean to integrate these techniques into that pipeline? What is the correctness of some of these analysis techniques from the receptiveness of the developers? And how do you bring some of these different code artifacts together, not just the code analysis, but bridging the gap between the code and the architecture and the infrastructure?
Okay.
That's what's on our radar going forward. That's
Okay.
one piece of it. So that's
Anything else you wanted to mention, Rod?
Well, this past year we've been starting to partner with our data science team at the SEI as well, and to see if we can apply some machine learning techniques to some of these development artifacts, and that's something that we're continuing to work on, and we'll be
So
reporting
there may be a
in the
blog
future.
post in the future
Yes.
on that. Excellent. Excellent. And both of these folks are frequent bloggers, so if you look for either Ipek Ozkaya or Robert Nord, you should be able to find some interesting things to read. I want to thank you both for joining
thank
us
you.
and
Always
updating
a
me on
pleasure.
the stuff I haven't been able to work with in the last couple of years. So this is all, I am hearing a lot more use of the term and apparent understanding of it even, in the areas that we work. So I think you're making an impact on the community out there, and that's what we're after. So thank you very much. And for our viewers, you'll see all of these resources we've talked about and other blog posts that are relative to this in the transcript for this. I want to thank all of you for viewing.
Thank you for joining us. Links to resources mentioned in this podcast are available in our transcript. This podcast is available on the SEI website at sei.cmu.edu/podcasts and on Carnegie Mellon University's iTunes U site and the SEI's YouTube channel. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.